Okay, well, hello, my name is Jeff, and I'm doing my first production video for YouTube, and the general topic is the Hue lighting system and how to apply it to a real-world residential lighting application. Now, you're looking at my wall of fame, which everyone who graduates from school anticipates they'll have this wall full of degrees, and they'll be sitting there in their beautiful office with their $1,000 sports coat and not have to get their hands dirty, and just wads of money will roll in. Well, we're going to go from this intro to the real world and show you what practicing engineers do and what their work environments look like. So hopefully this is not intended to be world-class professional. I'm not a lighting designer, though I am a Hue professional developer. But I did stay at a Holiday Inn Express once, and I know some very good lighting designers. I actually was on a stage crew in high school with Ken Billington, who was probably #1 in the world. That's homework for the reader. That was back before computers. We had slide rules and pencils in our brains. So sorry if I'm dating myself as well, but I'll take older and experienced over young, dumb, and you can fill in the rest. With that being said, we'll segue from the fantasy world to the real world. And hopefully this will not only provide a little bit of useful information, but will make you laugh once or twice. Thank you. Okay, we're out of the ivory tower and we're now in the real world. Any practicing engineer whose desk or work surface looks any cleaner than the one behind me is management. They're pulling your leg. They don't work for a living. Let me just step out of frame for a minute. You can see this is clean, by the way. Anyway, believe it or not, there's about $1 million worth of hardware on that bench between engineering development and actual cost of components and material. But we're going to talk about a subset of that today, the Hue lighting system, which you can buy at either Home Depot or a Best Buy. It has some amazing features and some technical limitations, and I'll show you the workaround for those. But we're focused on the color mixing and white fixture, not the white only fixture, which is a subset of the real system. They're list for about $40 a light bulb if you're an amateur or a luminaire or lamp. It's coming back to me. That's what we actually call a light bulb in the theater. So you probably wonder what's inside this thing. It looks like an A lamp. Well, let's start with that. I'm not wearing my t-shirt that says I avoid warranties, but in fact I do. This is the Philips Hue lamp without its injection molded cover, and they've actually done a very nice job on this. You have the AC to DC power supply, the control electronics, and then the LED head with the thermal on it, which actually, bear with me here, it unplugs. It's actually a nice little design. Now Philips has done a beautiful job on this. This technology, for those that are of the same vintage that I am. I was doing professional lighting design back in 1971, before many of you were born. So Some of this is going to require that you go on Google to do some homework. So anyway, the Hue system comes from a series of patents by a company in Boston called Color Kinetics, which sold their entire intellectual property portfolio to Philips, I don't know, around 2006 for almost $500 million. And some of these patents were quite valuable, and some of them were rather comical. Like the most famous one was patenting pulse width modulation, which is known prior art, But in my subsequent experience with patent law, whoever has the money wins. It doesn't matter who has a previous patent. If you have more money, you can break any patent. In my last startup, we broke the Hitachi patent, where they patented the sun, the moon, and the stars. And anyone that's in the lighting business or the control business will have bumped into the Hitachi patent. And thanks to some very bright guys out in Dallas, we just threw a couple of $1 million at it and broke that patent. So now we have a bunch of patents that maybe or maybe shouldn't have been granted, but again, it doesn't matter whether you have the patent or not. If you don't have the money to litigate or prosecute, depending on which field you're in, it's worthless anyway. So the key for young entrepreneurs to remember is the recipe is what's important. Keep that your trade secret, because if they can't make the stew because they don't have the recipe, then you've got a market advantage. Google Broadcom. Broadcom is very good at this. 96% of the internet packets go through Broadcom silicon. And if you go to Best Buy, take a Netgear or comparable commercial Ethernet switch and tear it down, there will be only 3 chip manufacturers in there. You'll find inside a gigabit Ethernet switch is one big chip and a bunch of transformers. And 9 times out of 10, the chip's going to say Broadcom on it, because even if you gave the Chinese the fab and all of the masks to make the chips, they couldn't get a single chip to yield, because the Ethernet PHY is black magic. And only Broadcom knows how to get that chip to yield, and they guard that very, very closely. We did the same thing at a small wafer manufacturing company I used to work at called IBM. We would have to send our process engineers over to Japan to teach them how to get the products that we made in high volume in Burlington and East Fishkill, New York, to yield. Because without the secret process knowledge, you can have all the documentation, you can have the math sets, you can have all the tooling, you can have the entire factory, and you can't get a single good die to yield. So anyway, so with that being said, it's a little slow. You can't do color organ with this, for example, music to lighting, because the latency is too high. It takes close to a second and it drives you nuts because of the latency. They have great color mixing. Both the white color temperature and the RGB color mixing is spot on perfect, as well as the dimming. It's got to be minimum 16-bit resolution, all of which is very good. You pay a price for this, however. It is what is known as a diffuse light source. In order to get the color mixing, they sacrifice the specularity or directionality of the fixture. So you have essentially what is optically difficult to manage as a fluorescent light in an LED package. So it suffers from data latency, the fact that it's not an optically perfect light source, which is, again, engineering's a trade-off. This is the price you pay for the good color mixing, is you don't get the directionality. And it has a further limitation, it's not bright enough for many applications. So in the real world example that we're going to show you today, which is lighting a guest bathroom in my home using this system, we have to pretty much triple the number of lights that most people, or I'm sorry, lamps that most people would think would be needed for this in order to get the luminous intensity on the surfaces of interest. And we've also used some techniques in semiconductor. It's called collimation. I believe that's still an accurate term in lighting. We can take a diffuse light source and collimate it by using a egg crate parabolic reflector that you'll see in the prototype fixture that I built for the bathroom downlighting on the sink. And that will overcome some of this, but you lose a lot of light, so that's why we have to put 3 of these in the downlight in order to get the intensity. But as you'll see, it looks pretty good. All right, well, that's a little better. We're working on the autofocus now. So you can see at the top you have this sconce-like fixture with 3 Philips lamps in it. This was originally designed to have incandescent candelabra bulbs in with these hideous glass shades, circa 1950s. And in order to get the intensity on the sink surface, I populated all 3 of these. And if you look very closely, you'll see the one in the middle has a band of black around it. This is an early attempt to create some directionality by masking that part of the lamp off, and it accomplished nothing. So we're going to show you how to wrap these, add some collimation, and create a much better look in the room. The makeup lights on the left and the right will stay exposed because those are designed for applying makeup if you're either a rock star or a woman. Any theatrical expert will tell you there are 2 keys to making things look great on stage or in movies. One is lighting, and the second is makeup. So in this video, we're kind of combining the 2. So since I'm trying to sell my home, you want something that the ladies will appreciate, which is being able to put on makeup for any occasion. And this is the beauty of the Philips Hue system, is we can create candlelight, nightlight, sunlight, varying intensities in these makeup lights. And the woman or the rock star can see exactly how he, she, or it will look in the environment in which they're going to be headed. And this is like magic. And then we'll show you how to collimate the top and wrap it in something that's much prettier, because as a lighting primer, 3 things are important: color, intensity, and direction. And in professional lighting, you should never see the light source unless it's purely decorative. Now, the one exception here that breaks the rule is, the exception that proves the rule are the makeup lights. In order to, the makeup lights are hideous, but they're designed so that you'll look like in the dressing room what you're going to look like on stage when the professional lighting designer has his way or her way with you. So that being said, we're going to show you a little bit about color temperature, which is really a scientific term, but it's the easiest one to understand. Chromaticity was invented by the French, I believe, and enough said about that, but it's far more complex. It has axes in color space combined with intensity, and color temperature is pretty easy to understand. So we'll talk about the primal stuff, which is fire. Candlelight is what we're most familiar with for intimate lighting. And we'll show you how the Philips system can instantly mirror that perfectly. So with that being said, I'm going to light a candle and bring you back and show you what is nominal 2600 degrees Kelvin color temperature, which we call very warm white or candlelight. Okay, so now you're looking at Hue set up. They have a pre-canned palette called Nightlight, I think. So you can see we now have the Hue lamps, the exact color temperature of that candle that's flickering in the background. Now those of you that are paying attention will see that we've got some cool white light in the background. That's daylight spill because I have the door open in the bathroom. Otherwise it gets a little claustrophobic in here. But this is what we're used to seeing. This is very primal. It's the romantic color because it's very yellow going towards red versus blue going towards purple, which is really the two ends of the spectrum for color temperature. Red on one end and purple on the other. Sunlight is blue-white. And then the more exotic, cooler temperatures tend towards purple. You may have seen these in some of the xenon or HID headlights that the kids have. They're almost purple. Very annoying, but that's cool. Blue is cool, red is warm, yellow is warmer. That's how color temperature works. It's really easy to wrap your head around. And X, Y, and Y for chromaticity, or then you've got positive and negative color addition, color subtraction, RGB values in video and windows and things like that. Lighting is a complex and pedantic subject, so I'm trying not to take you out into the weeds, but to try to give you some practical experience. So as you can see, that the Hue system can do candlelight perfectly. So let me go ahead and fix this color spill that we have from the daylight and bring you back. Okay, so now you can see that with the door closed, we've got a perfect match of candlelight versus the makeup lights versus the downlights on the sink. Pretty much perfect color temperature. Of course, your narrator's in the dark, but I do some of my best work in the dark. What can I tell you? The video's not about me. It's about trying to light this room. So if you're going to a soiree that involves candlelight, the Hue system can certainly allow you to apply makeup that does this, so you can create the romantic look for that. So let's start with how we fix these downlights on the sink so that they're a little more functional. And we do that by putting a sconce around it, similar to a teaser on a theatrical curtain, hiding the lighting instruments, and a fluorescent lighting parabolic collimator to reduce the spill and prevent you from seeing the lamp. So let me get that thrown in there, and then we'll take you back. Okay, so this is what I whipped up in the shop to deal with these three overhead fixtures. All it is a piece of foam core. I've thrown some wallpaper on, and in the bottom is the lens diffuser, which will collimate these three lights and also hide the light source. Let me put that in and I'll show you the difference. So I've dimmed down the makeup lights and brought up the overhead lights, and you can see how much spill these have right now. So let me try to hold this collimator up, and you can see the difference in how the room looks. So as you can see, we still have the same color temperature, the same intensity, but all of that spill off the top of the sink lights is gone. You can't see the bulbs anymore. You can just see the glow from the collimator, and it is a much more directional look. So let me get this permanently nailed up there with some masking tape, and we can show you how the sink looks, which is the object of what we're lighting. Okay, so now you're seeing the sink lighting with the collimator in place, and I'm going to pan you down to show you what we're actually lighting here. Which is the sink surface. So now let me jack this up to full brightness at this color temperature, and you can see the difference. Stand by. Okay, that is full brightness at the candlelight color temperature. And as you can see, it's not real bright, simply because the yellow LEDs and the Hue fixture are limited. It's not intended to be bright at this color temperature. But let me take you to daylight. So there you are, you're in daylight now, so you can see the difference between the color of the candle and the color of the sink surface. You can see it's very evenly lit and much bluer. It actually looks white until you compare it to the candlelight. And this is excellent task lighting for washing your face, brushing your teeth, that kind of thing. It makes the $3,000 granite countertop really pop. And there's very little spill of light. There's a little bit on the walls, but it's quite beautiful. Now I'll go a little bit bluer for you. This is what Philips calls Energize, which is a very pretty color as well, because this is actually still a little yellow. Okay, so this is Energize. It's even a little bluer. It's a little, I would say, the 6,500 Kelvin. Really almost sunlight plus a little blue. Okay, headed towards xenon headlamps kind of blue. Very nice color. And you can see the difference. It only looks blue by comparison to the candle. And of course, if we pan up a little bit, you can see that the two makeup lights are still the 2600 degree Kelvin color temperature.